Mhm.
Okay. So in yesterday's class, we had completed the correlation, and in today's class, we'll start with regression. We had started with regression, but it was you were getting confused a little bit. So it went
Me?
up my mind that
Regression. Uh,
we'll start with a fresh session for regression. Okay. So what is regression
Wait,
generally?
I was wait, was I confused? I don't think I was confused.
No,
I
no.
think I
I
got
was
it.
not able. Yes, yes. I was not able to deliver the topic correctly. I think so. So that's the reason
Okay.
the thing was getting complicated. So, what is regression generally? Regression, we have seen a scatter plot, okay? We have seen a
Mm-hmm.
scatter plot. So, when we take more points, generally take points which are lying, more points which are lying generally in a straight line. Then this line, which we draw, one line, single line, I'll make it a single line. I'll draw a little bit neat one, so things are clear then. Okay, so we can see that these points are lying in a straight line, okay? So I'll draw this line. I'll draw this line. There are some points which are lying outside the line, but we don't care about that in a regression line. In a regression line. This is a regression line. So regression
Yeah.
line. Okay. So in this line, we need to give an equation for this line. We need to give an equation for this line. So the line where it intersects at the y-axis. This is the y-axis, whole y-axis, and the line, every line has an intersection at the y-axis. There can be a line which does not have an intersection. If it is parallel to the x-axis, if it is parallel to the x-axis, then it will don't have any intersection with the y-axis. Yes or no, Zaid? Then
Mhm.
the intersection will be
Yeah.
zero with the y-axis, correct?
Mm-hmm. Yeah.
Yes. So if it is having the intersection with the y-axis, we name this point as A. We name this point as A, and it has something inclination with the x because I'll explain you here. Whenever whenever we measure inclination, we measure inclination, we always measure with respect to, we always measure with respect to, with respect to the horizontal axis, the horizontal axis, okay, the horizontal axis. So for suppose this inclination, we term this inclination that is there with the y-x axis, we name it as b. We name it as b. So the line which we want to predict, the y variable is called as the response variable. Y cap also some write y, some writes y cap because it is a predictor variable, response variable, and the x is the exploratory variable, which is also called as independent, and this is called as dependent. Okay. So
Yeah.
then we can write these representation of the strength of the points into an equation which is represented as y cap equals to a plus bx. Did you got that, Zaid? What is clear with
Yeah.
a and b? And when we will
Mm-hmm.
change the value of x, we'll get a unique value of y. Okay? Is it clear?
Yeah, it's clear.
Okay. So I'll explain you one thing. For suppose this point here on x is 20. So when I'll enter 20 here in this x, So it will be y cap equals to a plus b20, b into 20. So this point here will have an point on y here also, the perpendicular here. So when I'll put x here, it will give me the number which is here. For suppose here it is a plus 20b, a plus 20b, irrespective of
Mhm.
whether we don't know a and b. Did you got that? How it is predicted?
Yeah.
So for suppose,
Yeah.
see here, for suppose, see here, there was no point between these 2 points, but I can predict what will be the output for this point, which was not on the our what you say scatter plot. So how you will predict it? We'll see this point lies on the x-axis. For suppose it is 30. So what will be the point on the y-axis? The predictor response will be a plus 30b. Yes or no, Zaid?
Mhm.
Yes, so this is how it works. This is how the regression lines predicts the output of the response variable when we know the x variable, that's the exploratory variable, also called as independent variable. Now regression is clear, yes or no?
Mhm. Yeah. Yeah.
What happened that year, it was early morning and I was in very hurry as just came from the school where I teach, junior college. So I was in a very hurry, so I was a bit what you will say frustrated to deliver the topic. That's the reason I was not be able to be clear there. Okay, so this is
Mhm.
also called as y hat, pronounced as y hat. Just a minute, I'll drink some water, then we'll continue. Okay, so I'm back. So you can write down this definition. I'll take it on my board. So this is a very important definition. So we'll go on to the definition once. Okay. So what is regression? It's uploading. Okay. So what it is? A regression line is the line that models how a response variable y changes. So we are seeing the change in y. We are seeing the change in y, the change in y. Now we can comment about y. Now we can comment about y. Change in y when there is a change in x. When there is a change in x. Yes or no, Zaid? We have seen this. Correct?
Mhm. Yep.
Yeah. I'll write this down again. We are seeing the change in y when there is a change in x. Okay. So this was regression. Regression generally helps us
Mhm.
to do that. Okay. Now we come on to the first sum. So see here. Here is the data for about miles driven. Here is for suppose it is a I am question is like that. And that for suppose I'll update the what I'll say, manipulate the question that I am a seller. I am a seller, and the price of the car depends upon, does not I'm not telling depends. The price of the car depends on the kilometers the car has been driven. The kilometers the car has been driven. Okay. So here it is all about the data here. So I'll take on this data. Okay, so this is the data here. Okay, so what he
Mhm.
is telling to do is that he has given the scatter plot here. Okay, so what you can think about the scatter plot, say, see,
There's a negative correlation.
negative correlation, yes? Okay,
Mhm.
correct, negative correlation. With a correlation value, it was around minus 0 point something, minus 0.85. So it is a strong negative correlation. So you can see that there are many points here and here, but the best line that he has chosen is between these points, which is between all these points. Yes or no? On this line, only two
Mhm.
points are coming generally, but
Yeah.
the line is between all the points. Yes or no? The line
Yeah.
is between all the points, all the points. If I had would have drawn this line, so all the points would be below it. If I had drawn this line, all the points would be above it. But the system has drawn the regression line is such that it measures all the point and take the mean line, which is the mean line. I can draw infinite lines for this points, but this is the mean line of all the points. Okay, it calculates the mean and then do it. We'll see the formula, then you will get an exact idea there. Okay, so we have seen that it's y-intercept here, what it is, 38,257, and it's slope here. See, slope. Now this, when we measure like this, the inclination, it is positive. When we measure like this, it is negative. So here the line is likewise here, so the slope will be negative. Yes or no, say?
Mhm.
See, the if we are measuring like this also, the angle is obtuse. Yes or no? It is greater than 90. The
Yeah.
slope will be negative. Remember this. If for suppose this is the this is our y-axis, I'm just explaining you, this is our x-axis. Okay, if the line is like this, so we are measuring for an acute angle which is less than 90, so it will be positive.
Mhm.
If it is
Yeah.
like this for suppose, then it is obtuse here, which obtuse means greater than 90 degrees, so it will be negative. Here it is acute, which is less than 90 degrees. That's the clear thing. So here he has given the regression line here. Regression line is represented by the formula of a line. What is the formula? It's y cap equals to 38,257. Okay, plus b. What is b? Minus 0.1629 into x. So plus minus, it becomes total is minus. Did you got that, Zay? How it came?
Mhm.
Yes.
Yeah.
So now what we can do, if I have a car, now what does this regression line predict? See, I had a limited data. What I'll do, I'll take this graph again. It's very important. Every time we have a limited data, we have limited data. We have limited data. Okay, data. Correct. So we have for suppose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 cars only. Data about 16 cars. Data about limited data about 16 cars only. Now, if one car comes, this car comes, car for suppose it is a car, okay, this car comes and it is being driven for suppose, I'll take it as 90,000 miles, 90,000 miles, okay. Can you see
Mhm.
in the data, is there a point where the car has been driven 90,000 miles? Is there a point here? Exact 90,000? See here, 70 is there, 1 lakh 29 is there, 29 is there, so 24 is there, 75 is there, 83 is there, 34, 58, but no 90 is there. Yes or no, Zaid? Am I correct?
Yeah.
So
Yes.
how we will tell the price about 90,000? How I will tell the price? So what I'll do? I'll see where 90,000 is here. See, this is 120. This will be one around 1 lakh. So this will be in between this. So I'll draw a perpendicular here. For suppose I'll draw a perpendicular here and same perpendicular from this line, I'll draw it on the y-axis. I'll draw it on the y-axis. For suppose it is coming nearly about $25,000. Yes or no? So this is how I
Yeah.
can, this is how I can tell the price of any car which comes to me, which comes to me with any miles driven. Yes or no? Right? We can
Mhm.
tell or not. This
Yeah, we can
how
tell.
regression line helps. So we can calculate it also with this. We can, only cannot do with the graph. We can also calculate it. What is the this thing? Y cap equals to 38,257 minus. It will be minus. It will be 0.1629 into how much kilometer it was? 90,000. So it multiplied by 90,000. So what it will be? 1, 2, 3. 4 zeros will shift here, and this will be multiplied by 9 nines are 81. 8 carry, 9 twos are 18, and 8 26, 2 carry, 9 6 are 54, 56, 5 carry, and 9 ones are 9, 9 fives are 14, 14. So it will be 38,257 minus 14,000. So can you calculate this for me, Zaid? How much it is?
Mhm.
I'll do it. Okay. 38, 257 minus
24,
14, 660.
23.
23. See, near
Mhm.
about it is 23. Yes or no? And on this
Yeah.
line, the thing is very, the scale is very deep. We cannot go to an exact point on this graph because the scale in this, there are 5,000 rupees. Okay, so we cannot exactly measure the value on this graph, but we can measure the value, exact value of this graph. Yes or no? We got an exact value.
Mhm.
When a customer will come with me with this miles driven, that my car is driven 90,000 miles, so I'll tell you will get only $23,596. Yes or no?
Yeah.
Yeah, that's the thing of regression. That's the thing. This is the thing. I'll write it your note. This is the thing or task, we can say, task or analysis, we can say. One more point, analysis. That regression can do, that regression can do, but correlation cannot. Yes or no?
Mhm.
Yes. This is the thing. Okay, now we'll move on to the next. Then now there are different terminologies about regression. So this is the thing. Prediction. Okay, this what I have told you. Prediction. This. Come on, read this. Just I'll drink water. Read this prediction. I have explained you this
Mhm.
prediction. Y cap to predict the response variable by changing the exploratory variable. Read this just. Thanks for waiting. I'm back there. Okay, so now he is
Mhm.
explaining that we can use a regression line to predict the value of the response variable for a specific value of the explanatory variable. For the Ford 5F150 data, the equation of the regression line is, so this was the regression as the our what
Mhm.
we have done here. Our response variable on Y was price, and we had an hat on it as it is the, it shows that this hat shows that this is a response variable. Okay. and it had as 38,000, I think 257. Yes, 257. 257 minus 0.1629 into what I'll do into x into x. What it is x? It is the miles driven, and it was the explanatory variable. That's also known as independent variable. Independent. Okay, and this is the dependent variable as it depends upon the value of x. So only we can uh, predict the value of y. If x is absent, we cannot predict the value of. This was the case in it. Okay. This was the thing. Okay, so see, he has taken for 1 lakh kilometers driven, so it came to be 21,000. You can see that the kilometers, the miles we are increasing, the price is being depreciated. Yes or no?
Mhm.
Yes. Why it is like that? The miles we increase in our regression line, regression line line regression line, the output, the just a minute, I'm receiving a call. Okay.
Mhm.
Okay, thanks for waiting, Zaid. There was a bit a call
Mhm.
from one of my student, so I was talking with him. So the miles we increase in our regression line, the value of the value or the price of the car decreases more. Yes or no?
Mhm.
Yes, that was the thing. Okay. So now we'll move on to the second question. Extrapolation. What is extrapolation? Is like that. Extrapolation is use of a regression line for prediction outside the interval of x values used to obtain the line. The further we extrapolate, the less reliable the predictions are. Yes, I'll tell you. For example, we'll consider the example of the car only. Here I have taken this car. Okay, what I'll do, I'll paste it one more time. Okay. So for suppose I receive a customer for my car, for a car that he wants to sell to me or I wants to buy from him. So what I see that he has driven near about 2 lakh miles. Okay. Okay. So 2000 kilometer 2000 miles he has driven the car. So is this range available here?
Mhm.
Is this range of miles driven available on the x-axis? Is it there on the line, on the data which we had?
No.
Is there any point of
No.
1000 kilometers?
No.
No. So when we extend this line for predicting of the price for this 2000 kilometers, this is known as extrapolation. This is known as extrapolation means plotting, and extrapolation means we are going beyond the limit of the data. The data that we had received
Mhm.
had a limit near about 1,600, 160,000 miles in kilometers, and the lower range of 0 miles. Yes or no? But we are
Mhm.
going on to 2000 to 200,000 miles, 200,000 miles, which will be called as extrapolation. When we go for prediction uh, uh, away, below or greater than the range, below or greater than the range, then it is known as extrapolation. Did you got that, Zay?
Yeah, I got that.
And the more we extrapolate, and the more we extrapolate, the less the less reliable the prediction is, the less reliable the prediction, or we can say it as the value of response variable. Prediction means the value of response variable. Means what? The higher we go for the extrapolation, the value that comes out for the price, that will come out for the price, it will be less reliable. Yes or no?
Mhm.
This extrapolation says. Did you got that? Okay. So
Yeah, I
now
got that.
we will see, for example, the number of candies in the hand. Okay. Yeah, it is a very good example. Just read it. Just read it fast in a bit.
Yeah.
Okay. So what he is trying to say, what he is trying to say is that we have plotted this line that for a hand, the palm size, or what he has say that candy grab hand span, the longer the hand span will be, the more candy grab can be. Okay, so we had plotted a regression line
Mhm.
here, and the formula is to be minus 29.8 plus 2.83x, minus 29.8 plus 2.83x. So I'll take this graph
Mhm.
here onto this. Okay, okay, so you can see that line is the regression line was y cap equals to this. What will be y cap? For what variable it will be? Number of candies. Yes or no?
Mhm.
Candies, and will be minus 29.8, because it will here it is not clear here, but it will intersect on the negative y-axis. It is intersecting here on the positive x, but it will go on to the negative one. Okay, just he has drawn a rough figure for
Yeah.
this line. Okay,
Mhm.
29.8 plus 2.83 x. Okay, so
Mhm.
so now if the range of the hand span, the data it had, it was around 25, it was in centimeters or inches. It was
Mhm.
in centimeter. It was the range was 25 centimeters. So for suppose I want to predict the range, the number of candies in a 30 centimeter hand. So what I'll do, y cap equals to minus 29.8 plus 2.83 into 30. So what it will be around
Mhm.
minus 29.8 plus 2.83 into 30, it will be 28 into 3, 56 and 64, 74, 84. 84 point for suppose it will be 86 for suppose I'm taking just round off. 86.8 will be okay. When we'll minus it, it will be around 49. Yes or no? 49 candies. Correct?
Mm. Yep.
49 or 43 was so this value of number of candies in the hand span of 30 centimeter will be less reliable. Yes or no? Will be less
Yep.
reliable. We will rely less on this. But if it would be
It's
in
not
the range, for
43.
example, it will be for 22
Mm.
centimeters. So what we'll do prediction, this prediction. Oh, we have to go perpendicular. Yes. So for suppose for this prediction for 22, see your 22 is there. So what? So for this prediction, it will be more reliable. For suppose 30 candies will fit in his hand. Yes or no?
Mhm. It's actually 47, not 43.
This will be more reliable. Yes. You were saying anything?
47, not 43.
Correct, correct, correct. It came to be 43. So number of candies increase, and that's the thing. Did you got that extrapolation and all? Come on, read this question.
Mm-hmm.
What's the question and tell me the answer. Come on. 22. We have done it. We have done it. 22. I have done it for 22 only. But you need to calculate by the formula. Come on, calculate it by the formula and tell me. By putting 22 into this formula, y cap equals to minus 29.8 plus 2.83. Come on, do this sum.
33.46. 30. Yeah.
Okay. Okay. So that was the thing.
Mm-hmm.
This is how regression is used. Come on, do the B and C also.
Mm. Oh, see, it's okay. Added one.
See, how confident are you in each of this prediction? Explain. So, Mr. Tyson, young daughter, has a hand span of 12 centimeters. So, if we are looking at to this C, this, he is going on to the lower side. Yes or no? He is going on
Mm-hmm.
to the lower side below 70. Below 70. And I do this on my board. Bill, he is going on to below 70, which is 12. So, this will be less reliable. Yes or no?
Mm-hmm.
Yes. So, you will write the explanation that I'll write the explanation as in both the cases, as in both the cases, the number of candies have been obtained, have been obtained, but in the second case, as the hand span was 12, as the hand span was 12, and it was below the range of our data set, below the range of our data set. So the extrapolation, so the extrapolation strikes onto strikes onto this prediction, strikes onto this prediction means the number of candies, the means the number of candies that her daughter can hold, may be less reliable on our calculation. Did you get that answer?
Mm-hmm.
Yes, this is how you have to write the reasoning. Reasoning can be different depending on the language and the sense of writing and sense of reasoning. It can be, in your case, it will be more explainable. So see how he has written.
Yeah,
Just
I
read it
got.
once.
Yeah, I got negative 416 as well.
Correct. Yes, that's good, man. So you can see minus 4.16. Is this she can hold? Can the number of candies hold can be negative? Right?
No.
No, so it's the wrong value. So this is how the linear form may not extend to hand spawn till so much small. So what we have to do, what we suggest here in regression, I'll give you one, what you'll say application of regression. Regression is the backbone of machine learning, is the backbone of
Backbone of
machine learning.
machine learning.
Yes, because see here now the we can predict any span between 17 to, for example, it was 25. Okay. Now, if we want to calculate the number of candies for a 12 centimeter hand span of a daughter, we need to bring and train the model. We need to bring and train the model for the sample data of children. We need to take the sample data
Children?
of children's hand span. Here, the hand span was not for about children. No? We need to consider a model or a sample data for children's hand span and see how much candies fit in it. And then we can see for 12 centimeter. Yes or no?
Yeah, I
We'll
understand.
train
Yeah.
the data on a sample data of children's hand span, then the value can come correct. Did you got that? This is the backbone, this regression line. This is the backbone of machine learning. This is how we draw a regression line. Then what you do, we do least square regression on it, and then we predict the specific outputs of it. You have seen that when we buffer to the internet and when we are looking for buying something from any of the e-commerce website, we see that advertisements comes. This is the algorithm of the machine. It judges from our search that what we need, what we want. If we are seeing a YouTube video for a specific handset of say Apple iPhone 15. So the advertisement when we will go through on our Facebook or Instagram, we'll see advertisement related to it. Yes or no? So this is the
Mm-hmm.
algorithm that they
Yeah.
have designed in the system. This is all machine learning. Okay. Now
Mm-hmm.
comes the residuals. Now comes the yes. Come on, read this
Let's
residual
see.
once. I'll just drink water. Today is very
Alright.
okay. Thanks for waiting, right? So what are residuals? Residual is a
Problem.
part of regression line. I've told you, I've explained this to you further. Residuals. So what are residuals? We have seen that when we draw a line, for suppose I'm drawing this line. Okay. 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 So see here some points are left and here also some points are left. I'll draw a neater one because it looks very congested there. Okay. So how will be the line? It will be the mean distance of all the point from all the points, and it will be like this. It can not go through the maximum points to the maximum points. It can be other also. We have seen in the previous example, like was like this. I'll draw just in the rough. Like it, there were only 2 points through which the line was going, and there were multiple points here on the left also and on the right also. Okay, so but it is the mean distance from all the points, and the mean distance, then the line passes through some of the points. Okay, so what is that? We are leaving these 2 points, but these 2 points are in consideration. These distances, the distances of the point from the line, is called as residual, that we are leaving. This residual, or also we called as errors. Did you got that, Zay? What are residuals?
Mhm.
The
Yeah.
points which are leaving behind, which are not coming on the line of regression. This is line of regression. Okay, which are not coming on the line of regression. The distances of this is called as residual. So we'll show the definition. Residual. See, figure 3.8 shows a scatter plot of the Ford 5150 data with a regression line added. The prediction error are marked as bold vertical segments. Prediction error, the errors that there are in the prediction. For suppose, for example, in this data, see here, in this data, here, see, there was a point for 22. Yes or no?
Mhm.
There was a point on 22. And what was the value the point was representing? Lesser it was representing. Okay, see here in the data we look for the above example here, it is there, 22 is there. Yes. The
Yeah.
data is not given there, but it is there, and it is less than the, if we consider the line, generally the equation gives the value here, around here. Okay.
If the residual is less, then it'll be negative. If the
Correct.
residual is positive, then it's positive.
Correct. But the point must come onto this. But where it is coming according to our equation here. So this, the error
Mhm.
it is producing due to this point, as 22 was there in that point. The error that it was producing is called as residual. Yes or no? For the points which are
Mhm.
not on the line. It will be very correct for the points which are on the line, this point, on the line, which are on, but which are not on the line, it
Yeah.
will produce some residual, that is the error for such points. And there are many points for which it is producing the error. Yes or no?
Yeah.
Yeah, so this is the thing. So this is known as residual. Okay. So now a residual is a difference between the actual value of y and the value of the predicted by the regression line. Okay, that is residual equals to actual y, that was here. What I have told you. I'll take on this again. Graphs is very interesting. Okay. For example, see here for this point, for suppose 18, for 18, it was for suppose near about for hand span of 18, it was 15. 18 hand span hs, it was 15 candies. But due to the line where it went, it gone onto the line. When we use that this equation y cap equals to this equation here and calculate it, it will be minus 29.8 plus 2.83 into 18 for suppose. So 18 to the, it's near about 18 to the 36. Okay, 36 and minus 229.8 and 36, it will be 7 for across. So it is giving a lesser value, 7 for suppose. Here it is giving, according to the line, it is giving lesser value. Yes or no? It is giving
Mhm.
lesser value, but the value was greater, 15. So this error, y actual minus y predicted, y actual minus y predicted will give you the value of, residual. Is it clear?
Yeah.
Okay, that was residual. Okay. So this is how we'll calculate the residual of the price of the car that we were thinking of for the 17,583. See here, what we'll do, what he is doing in this data set. In this data set, here we had an here 70,583. We had a price for it, 21,994. Now what we'll do is, according to that, according to our regression line formula, we'll calculate it. Okay. So for suppose
Mhm.
what is our regression line formula? Okay. 38,257. Sorry, first I'll multiply it. Okay. 0.1629 into into uh, into into 0.169 into 705 70583. So it is 11,497. And what we have to do, we have to add, correct? We have to add
Mhm.
this, means subtract this 38,257. minus 38,257. So what it will be? It is coming in minus, but it will be in plus. What it is? 26,000. It is 26,750. But
26,759. Yeah.
what is the actual value of the price of the car?
21,994.
Yeah,
So therefore, there will be a
like
positive residual.
26,569, and the predicted value was this 2759, 759, and the actual value, what was it? It was 21,994,
21,000.
21,994. So what was the residual year? Around it was 4,759. Yes or no? It was
Mm-hmm.
4,760, around about. So this is the residual. Did you got that?
Yeah.
Yeah, that's the residual. So what now we'll do? We'll fit the line across, considering all the points here. We'll see that method. Did you get that? How, what is the meaning of residual prediction and all?
Mm.
Extrapolation, everything.
Yes. Mm. Yeah.
Okay, so this is again an example for candies. Here in the scatter plot showing the hand span. Candies grabbed by each student here. This regression line is
Mm-hmm.
like was this. Okay. Okay. Now what he has done, he has calculated the residuals. You can do this example. So the less the
Mm-hmm.
residual, okay, the less the residual, the less the residual, less, remember this, less the residual for
Yeah.
each data point, the accurate will be our prediction. Accurate, the accurate will be our prediction. Did you got that, Zay?
Mm-hmm.
Yes, this is the thing. Okay. So the next thing now is interpreting a regression line. So see, y-intercept and slope. I've explained you this. Yes or no? What is slope? That
Mm-hmm.
comes with the variable. This b1 is known as the slope. Slope means inclination. And what is y-intercept? This is the a. Yes or no? There is a thing that you can calculate the y, for suppose this is the line y equals to a plus bx. So when we keep x equals to 0, we get y equals to a. Yes or no?
Mm-hmm.
Yes or no? This is known
Mm-hmm.
as y-intercept. This is known as y-intercept. And this b is known as slope, which gives you the value of inclination with the inclination with x-axis. With x-axis. This is the thing. Okay.
Mm-hmm.
So
Yeah.
this is the parameter and the terms in regression line. Yes, what he does, he explains it after discussing the things with practicality. Okay, so interpret the slope of the regression line. So come on, tell me the slope and the what you'll say y-intercept of the regression line. Come on,
It's a positive slope.
positive slope with 2.83, and the y-intercept is
Y-intercept is negative 29.8 or
yes.
20.
If so,
Yeah.
interpret the y-intercept. If not, explain why. Okay, so what we have to interpret the y-intercept. The y-intercept does not have meaning in this case, as it is impossible to have a hand span of 0 centimeter. See, this y-intercept does not have a meaning here. This because it is not done for here for the 0 centimeter here. It will be for suppose it is 0 centimeter downside here. It is meaningless. That's the thing. So the next
Mm-hmm.
thing is least square regression. Least square regression. This was simple regression. This was this that we
Simple
studied. This
regression.
was simple regression where there was simple regression where there was residuals in our data. Residuals implies to errors in production. Yes or no? Errors in
Yeah.
errors in prediction. But when we will perform least square is a method for regression. Least square, I'll explain it to you tomorrow. Least square, then the residuals will be less. Residuals will decrease by this method. Residual will decrease. Did you got that? That's a method. We'll see it
Mm-hmm.
tomorrow.
Yeah.
Okay, so inshallah, it's the call of the day. So
Mm-hmm.
inshallah, we will see all the things, least square regression and all the things tomorrow. Okay, done for today.
Yeah.
Assalamu alaikum.
Alright.
Take care.
Walaikum salam.
If anyone is there
Okay.
or has AP statistics class, then please suggest. Thank you very much, Zaid.
I will. Okay. Allah Hafiz.
Allah Hafiz.